In this video, I'm going to do a step-by-step example, kind of comparing continuous extensions for piecewise functions like this. So what we're going to be doing here is we're going to be determining the values of a, or in the other example, a and b, that would make these piecewise functions continuous. So I'm making this video actually based off of a conversation I had with one of my students the other day who did not get why do we have this a and this b. It's like so many letters, and was just kind of like, I don't understand what they're supposed to do, this, that, and the other thing. And I thought this was a really great conversation that people could benefit from, so I wanted to make a whole video on this. So just FYI, I actually love when you want to know why something works. So even if you are not one of my direct students, but you're watching my videos, if you really want to go into the reasons why and you leave me a comment, I will probably think pretty deeply about that. That gets me very, very excited to make more videos. So just a note here. So calculus is actually a really good habit, or is a good class to get into the habit of understanding why. I think a lot of times it takes more time at first to get why things work versus memorizing a bunch of steps. And I think when you go through algebra and a lot of math up until calculus, you kind of get by just memorizing a bunch of steps. You have no idea why it works. You just know that if you do this, it works. That doesn't work anymore in calculus a lot of times. There's going to be a lot of times where you'll be asked something where you really have to think pretty deeply about the idea. So I'm going to show you kind of how to get into more deep thinking in this video. The thing is, once you get used to thinking and understanding why, it becomes a lot easier to retain some of these topics and understand the harder topics. So I can ask you a harder question, and if you really get why something works, you can sit with that discomfort, think about through the details, and then kind of figure out why it works. So this is not something, like I said, that people usually do at first. It's something that you have to work at. I wasn't very good at it either when I started out in calculus, but I practiced and I really got in the habit of it, and it got a lot easier for me to start understanding why. So I want to push you to kind of do that. Okay, so back to these. So we're going to figure out everything with these, and before I start, you need to truly feel okay with piecewise functions. If looking at those are just making you really nervous because you feel like you don't really get them in the first place, you should watch my review video. I made a review video of piecewise functions just for calculus students to kind of walk you through all the details. Okay, so here's the idea. This is a piecewise function, right? So this is usually what we think of as piecewise functions, but what this example is getting at is it wants us to manipulate the piecewise function to get something like this, where it's connected, because this is not continuous, this is. Or in the case of the three equations, I have, like normally I would have something like this, but what this question is asking us to do is manipulate this piecewise function so that we get something like this. So we're trying to figure out how do you actually do this. So the first thing I want to do is I just want to think about what a normal piecewise function is like. So I just wrote a totally random one here. I just made this up, but think about how you actually would graph something like this. So to graph it, you need to use like these points here, right? And then you are really graphing this line and you're graphing this line. And this is kind of like where you cut those lines off. So that's the idea behind that I just want you to kind of remember, because we're going to be taking what we know about piecewise functions and still using that in this example. So now I want to compare kind of that normal situation to this situation. And the a always seems to really throw people off. So the first thing I want to think about just is, what sort of graph is x plus a? So a is not usually there. You have to actually like fill it in, right? So a is going to be some number. Remember that. Now, if that's really throwing you off, like the a, just write out a couple of visual representations of just something with a number in it, right? So it could be something like x plus 3 or x plus -2 or x plus 10. So these here, what are these? What is the graph of these? Well, these are all lines. So x plus a is some line, right? And a is the y-intercept. So in this particular situation, I'm trying to figure out the y-intercept. So I want to think a little bit more about this. So like I said, this part here, so we said this is a line. So I want to imagine some possibilities with this. So let's bust out the graph here for a moment. And I just want to focus, actually, I don't even want to think about these for a moment. Just forget about this. I just want to think about this x plus a just visually. So like I said, so it could be like x plus 1. This is what x plus 1 would look like. Or x plus -2. So it's just kind of moving it up and down, right? Or x plus 4. So here's kind of what's happening. So A is basically going to move the line up or down. That is really what A is doing. So you want to keep this in mind. And then remember, this is actually a piecewise function, right? This is part of a piecewise function. So you wouldn't have the whole line, right? Instead, you would really like break it off here. So at x equals 1, like, so you would just have this part of the line just over here, right? So if I just wanted to draw that out, what these possibilities look like in the piecewise function, they'd look like this. So this is basically what A is doing, is it's just how it's like moving this up and down. Okay, so now we have to factor in what we were actually talking about in this problem. So we want to know, how do you determine what the right A is? A could be any one of these things, but we need it in a very specific context, right? So we need to take into account the other part of this function, right? We haven't actually thought about the 3 yet. So let's just think about that 3 for a moment and get rid of the other half of this graph. So if I just graph this part here, I get this. This is what this part of the piecewise function would look like. So thinking about this then, I need to ensure that I get the overlap at this point, because remember, we're trying to make this into a continuous function. So I basically need to make sure that my function starts right here. So in other words, I need the 2 pieces of this piecewise function to literally be equal at this point. Okay? So I need these 2 pieces to be equal. So I'm going to set them equal to one another. Now, this isn't enough, right? This is just saying a general function x plus a equals 3. This does not represent the part where we have the overlap. So the question is, how do I represent that they need to be equal at that exact point? Remember, we were talking about this point right here. How do I ensure that they are going to be equal? Well, that's where you're going to take in, like I said, this into account. So basically, this is where they should overlap at this point, x equals 1. So what does that mean? We need to plug in x equals 1 into this so that we ensure that we are talking about the exact point in the function where they're overlapping. So I'm going to replace the x with a 1. And so now, look, after replacing x with 1, we are left with only a, right? So this actually worked out quite nicely. So a lot of times people get really hung up on the a. What am I supposed to do with it? I don't see this and the other thing. But the reality is, if you just think about what you're trying to do with this, you want these 2 pieces to be equal at this point. If you just account for that information, what ends up happening is now we are in a situation where all we're left with is a. We can easily solve for this, right? So if I want to solve for a, I just subtract the 1 and I get the a equals 2. So that's it. Now we're done. So now we have to restate what the actual continuous function is. So here it is. The continuous version of this function is this. So notice I've plugged in my a, so this is going to be x plus 2 instead of x plus a. So this is the exact function that I was looking for that overlap. And if we take a second just to graph it out, so here was that x equals 3, and now if I plug in my x plus 2, so there we go. So this is what we wanted, right? This was the whole point of this. So okay, we're good to go. All right. So now I want to just summarize that really quick. So to summarize this, so if I know one part of a piecewise function like I did in this last example, and then I have some letter a in there that's creating all of these different possibilities, the reality is that I know that there's only one that I want, right? I want the piece that's going to just extend this part of the function into a continuous function. That's what I'm being asked to do. So all these other options, I don't need them. And so then I just have to really ensure this overlap. So to ensure this overlap, you just need to set the 2 pieces of your function equal. And then you need to also use this x value here. So there's 2 pieces of information. It's not just enough to set these 2 equal. You also have to take into account where they're overlapping. All right, so now let's pivot to 3 pieces. So how does this change things? So now I've got this A and this B. The thing is, you shouldn't let the A and the B throw you off. If you set this up right, it's going to kind of reveal itself what needs to happen. So remember, I have kind of like a situation that's like this, and what I'm trying to do with this is I'm trying to ensure that this happens, right? Now, this is a little bit different from the last question. So in the last question, we had, you know, the one place where they connected. So now I want you to note the connections in this case. In this case, there are actually 2 connections, right? So I have the connection up here and I have the connection down here. So if that's my situation, what does that mean then for my problem? I want you to think about this as we're going through this, because this is gonna change things. Okay, so now what I want to do is I want to think about this for a moment, and I also want to think about just what kind of graph is this AX plus B? What is the actual graph of this? So remember, you're going to put numbers in for A and B. So maybe you want to take a second just to write out some possibilities. You can put in anything that you want for A and B and make maybe a couple different examples of it. What type of graph would that be? So once again, it's still a line, right? It's really in the form mx plus b practically, right? So it's still just going to be some sort of line. So basically now in this particular example, it just so happens that we're figuring out the slope and the y-intercept. And in these equations, you can be asked to do anything. You can be asked to find the slope, you can be asked to find the y-intercept. So it doesn't really matter, like it'll still kind of work out the same. So we're going to use now the same technique that we were before. So we want to use this function and graph what we can off of this. So I know I can't graph ax plus b, right? I don't have enough information to do that, but I can graph the other 2 parts. So I want to look at these 2 pieces. So I'm going to look at them on the graph, and if I graph those 2, they're going to look like this. So basically now what I want to do is I want to figure out this part in between them, this line. So how do I get this part here? So what is this? So this part here is 3, so that's this equation here. And then this part here, this is my ax plus b, which is kind of a mystery. We don't know what, the a and the b are, but that's okay. So just how would I set this up to get this connection? Well, you're going to have the ax plus b equal to 3. So just like we did with 2 equations, we're going to do that with 3 equations. So we're going to set the 2 pieces that are connecting, we're going to set them equal to one another, but we're not done, right? There's one other piece of information. This does not represent the connection at that point. So how do I bring in the point? I need to use x equals 1. So where did the x equals 1 come from? That came from this information up here, or look at where they're connecting, right? So they're connecting here literally at x equals 1. That's the change point. Okay, so now let's pivot. What about this other connection? How do I get to this? So to get to this, so now I got to think again, right? I have this piece here. This piece here is -3. And then I have the little middle function here, which is still this. So it's the same idea, right? It's you're going to set those 2 pieces equal to one another. But once again, you have to make sure that you are ensuring that it's happening at this point. So at what point is this? Maybe you want to pause and think about this for a second. So this is happening at the point x equals -2. And how did you know that? So it's either you can look up here, this is where the change is happening, or if you look at what you're graphing here, you can see, right, it's changing at x equals -2. So visually it makes sense. And sometimes you might want to draw the picture to really help wrap your brain around this. Okay, so I have these 2 equations now that I've set up. So let's summarize them. So I had ax plus b equals 3, and I said that I needed to use x equals 1. And then I have ax plus b equals -3, and I said I had to set x equal to -2. So now what I want to do is I want to take this information and I just want to like rearrange these 2 parts here by plugging in these x values. So if I do that, this will actually turn into this now. So the first x dropped out, right? It was just 1x, or sorry, it was just 1a, so just a plus b equals 3. And then the second one, if x is -2, now this becomes -2a plus b. So here's what I've got. So now what we're left with, this is a system. This is like from your basic algebra days in high school. So basically, like once you kind of set these things up, anything can happen from here. And this is kind of why, like, it's not just a procedure that I can just tell you. You have to kind of go on this journey, and then you get to a point where it's like, and now you just do the algebra. But the algebra can be anything. It could be a system. It could be just something as simple as solving a linear equation. It could be you have to factor. It could be a square root. It could be literally anything. So you kind of just have to figure it out from there. So here, now that I see, oh, I've got two equations and two variables, it happens to be in this situation that I have a system. So now you're going to solve that system any way you want. So what I'm going to do actually to solve this particular system is I'm going to use elimination. So I'm going to multiply this equation here by -1. Although just as a note, if you don't like using elimination, if substitution is what came first to you, that's fine too. Like you have some creative freedom, so to speak, with the algebra. However you want to do the algebra is fine. And so in this case, there's two routes you could have taken, elimination or substitution. Okay, so I'm going to multiply that equation so it becomes this so that I can eliminate. So then I can just add everything straight down to get this. Right, so the b's drop out, and then I can just solve for a. So I divide both sides by 3, and I get, so a equals 2. And then I'm going to plug this 2 into this equation up here. So I'll just plug it into that so that I get -2 minus b equals -3. And then I can solve for the b, so I'll add the -2 over. So I get -b equals -1, and then you get obviously just b equals 1. And so now I have the two pieces. There's my a, there's my b, that's what's going to go in here. So let's restate this. So the continuous function now is going to be this. With my a and b plugged in, this is now 2x plus 1. So if you are a visual person, or if this is really throwing you off, you want to use the graph alongside this. So this is not something you just want to do procedurally if you're truly trying to understand why. So if you want to double check your work, then what you want to do is you want to graph it. So we've got those two pieces that we already had, so the two constants. So there are those two pieces. And then if I graph the middle part now, just to make sure this actually works. So if I plug everything in, so look, I've even got my slope. Here's up 2 over 1, here's up 2 over 1, and there I am at the y-intercept, right, of 1. So everything worked out perfectly. So this is the right function, so I can see this. So we are good. So that's kind of the idea behind this. So it's all about kind of connections and then understanding these points here. So just a parting thought on this. So this is an extension question. So what if I had this situation? So what would I do here? The question is, how many equations would I be setting up in this case? And I'm just going to let you think about that. You can like draw it out if you want, if you just want to see if you've got it. So that's your question to think about. And otherwise, that's it for this one. So I know this was kind of a longer one, but I really wanted to draw out some of these ideas. So hopefully this was helpful. If you find this helpful, please leave me a comment or like the video, or definitely subscribe to my channel. That is very helpful for me. I am trying to build a really high quality calculus help channel and general math channel on YouTube. So thanks guys. I'll see you next time.